Hello, hello. Oh, yeah, it starts working. Wonderful. Yeah, sorry for running a couple of minutes late. We have like delayed speaker transition. And wow, those are nice slides. That means I do not see your faces. So if you are making faces, then make sure you are. Yes, yeah. Give me some other signal, like if a coffee or something else. So anyway, let me start with a couple of questions for you folks. So how many of you here is using open source software for development? Yes, yes. Some hands, some not hands. Okay, that's good. Then you're in the right room, because the open source is something I'm going to talk about beyond specific MySQL questions. Now, item number 2, who are you folks? So let me understand you better. How many of you here are developers, engineers, writing code by the day, night? Yeah, okay. Not surprising. How many of you are actually more like DBAs, so database reliability engineers, kind of more database focused? Okay, yeah, a few hands as expected. And SREs, sysadmins, kind of general ops people, not database specific. Anybody would find it in that role? Yeah, okay. And any managers or some? Okay, yes, one person raising hand very shyly. Okay, yes, you see, I can still see despite all that attempt to blind me. Well, anyway, so folks, how do you feel about databases, right? When you have in your application running database, what first thing comes to mind? Anyone? You just shout a word. I need a DBA. Okay, that's more than one word, but yes, I will accept that. Well, anyway, what I often see with developers running databases is they don't kind of like them. Like databases are messy, complicated. They, for some reason, can't just work, right, and tolerate all that abuse nicely. And I remember it goes to the point of database can be blamed for everything. I remember a few years back coming to the customers, and you know, exactly at that point they have their website goes down, and they saying, "Oh, that's wonderful, you're here. Let's check what's going on with our database." And I say, "Well, why do you look at database first?" Well, because it's always a database. Right? Anybody had that thing like, oh, well, database is a very often troublemaker, which causes the downtime, performance problems, and discord. Well, that can be quite common in some environments. And that, I think, gives us to the real problem what a lot of folks, those days a lot of companies, having a hard time finding enough engineers, right? You can just see that going to the hallway here, right? There are a lot of people just saying, you know, please join our team, right? We are so wonderful, right? And so on and so forth, right? And I think in a database space, in particular, it's even harder because databases are complicated. And if you give your database to the care of bad engineer, often, well, you will be actually worse off, right? Because unlike many things in the software developers, in database world, often we do not have second takes, right? If you fucked up your database and you didn't have backup, you're kind of screwed, right? It's not like, oh, you know, let me fix the code and deploy it again. Right? That may not solve a problem anymore, right? And we hear about that kind of issues all the time. Maybe some of you heard, I think last month there was this Atlassian debacle where they sort of run the script in production which were not intended to, and their backup system wasn't quite perfect, so it took them many weeks to bring back the customer data. Well, not a good situation to be, right? And I think another interesting thing is what a lot of modern engineers, unfortunately or fortunately, they don't quite like databases anymore. Databases are not super sexy, especially if you look at like your traditional core operational database, not some database you use for some machine learning, artificial intelligence, this kind of cool stuff. So what is really the need, what everybody has with databases? If you would describe it with one word, that would be to simplify. Right? We are having the engineers, which may not have a lot of experience of databases, and we often have a lot of databases right, to cover, especially in large deployments, and they are looking to say, hey, how can I have my database to operate as simple as possible? Now, if you are looking at what is being presented in the industry, it is typically going to be a lot of cloud-based proprietary databases. Anybody heard any of those? Right, so what we see, a lot of cloud vendors say, well, you want the database to work like magic. Well, there are the options. They are fully managed, and you can just go ahead and use them, scale by a credit card, and you will allow Jeff Bezos to pursue some expensive hobbies like going to space, right, or dating a hot journalist, right? Well, good for Jeff, right? Well, in reality, though, I think that means what you have to take the freedom for convenience, right? Which is a very convenient and seductive thing to do, but that may not be very good over long term, right? What I think also is interesting here, as somebody who was in the industry for now, more than 20 years, that reminds me of a situation we saw in the late 90s, early 2000s in the open source and kind of like a conventional development frameworks. I remember a lot of friends from Windows world saying, hey, you know what, we have such a fantastic development tools, and you guys in open source and Linux, you're still writing the code in VI. That is so freaking Stone Age. Well, but guess what? Now we have a fantastic open source development tools, right? Or at least maybe proprietary tools for open source frameworks, which we can be highly productive in the open source ecosystem. Another example for me was with Linux and Solaris. At the same time, I remember some friends working with real operating systems, both in Windows NT space, as well as HPUX, Solaris, wherever, 64-bit, real Unix stuff. And Linux, compared to that, was a toy, right? I mean, it could not address more than 4 GB of memory because it was 32-bit operating system. It even didn't support file sizes more than 2 gigs. Right? At least at the conventional hardware we all used. Well, guess what? Now, 20 years later, Linux is pretty much ubiquitous, and then Solaris is, well, mostly seen in museum. So what we see now, I think, is a similar thing happening in the cloud space, where you can take some cloud vendor, which provides a very convenient environment for development, deployment, very high value services, but well, that creates you of course, log in that environment. At the same time, we see their alternative coming up, now based on Kubernetes and related technologies, cloud-native computing foundation, and so on, right? Which is building that whole environment and ecosystem to provide the similar usability and convenience right without lock-in. By the way, anybody runs Kubernetes here? Anyone? Okay, yeah, good. Quite a few hands. Now, here is another image. And this is the kind of magnified cloud-native computing foundation landscape. And you can see here what there is so many companies, services, solutions really working and innovating on improving this landscape. It is much more than any single vendor, even as massive as Amazon can do, right? Of course, sometimes you'll find that there is maybe a little bit too much choice. Well, but too much choice is something I would honestly prefer to no choice. Now, that does not make me against the cloud, right? More for the cloud, but in its original sense. So this is the slide I pulled from a presentation of Amazon Web Services from now more than a decade ago, when they're explaining to people what the cloud is, right? And they made this idea saying, well, you know what? You don't generate your own electricity, right? In most cases, that doesn't make sense. You just can go ahead and buy the electricity from a variety of vendors. It's cheaper, more convenient, and so on and so forth. So we should do this the same with the compute services. Well, and that makes sense when you think about something which is commoditized, like your compute resources, like maybe provider of the Kubernetes interface, if you will. Now, when you switch, in this case with a much high-level proprietary services, it becomes different. Very similar to saying, hey, you know what? Now, because you're having an electricity provided for us, you only have to get your fridge and a microwave and laptop also from the same vendor, and guess what? It won't work anywhere else. Not very practical, right? So in my opinion, what makes sense when you are using the cloud, which is really life-changing, convenient, is to really use that more on a commodity infrastructure provider space, and then get the more value with the open source software. Right. Why I'm talking about that? Well, we at Percona invest a lot of time specifically at solving a problem for the open source databases. How to run open source databases in this Kubernetes ecosystem. And while Kubernetes is something which was designed for stateless application first, right? That is something which has actually became quite good rating stateful application over the last 5 years or so, and many folks are running databases in Kubernetes environment successful. What we provide at large extent is their Percona platform, right? That is solution of software and services together to run open source databases, not necessarily in the cloud, right? But in the cloud, you can really optimize and automate much more things. And this is kind of specifically how I think about that. You can see what, from Percona standpoint, we both have solution for like different foundational database software, both to run it on Linux as well as Kubernetes environment, as well as Percona monitoring and management as a solution which provides a single pane of glass, for everything and allows you to conveniently monitor, manage your databases. This is an open source project. What is important? By the way, as all the other open software I mentioned, right? All the software Percona ships is open source. We don't do open core. We don't have some or especially only crippled version available open source, right? Everything is open source to the extent we can. Like actually for MongoDB, because MongoDB changed the license to non-open source, but is source available. Our derivative from it is source available as well, but everything else is open source. Anything. So that is what Percona monitoring and management is, and that is what I will show you today, what we have and how to use it. Now, with the fact what PMM is actually our Percona software is open source, that means that if you are passionate about their open source and databases and really want us kind of to accelerate their open source landscape being substantially superior what proprietary vendors can offer, join in and contribute maybe to Percona projects, maybe to some others. And there are also many companies, including Percona, which are hiring engineers to work on open source these days. Okay. Before I switch to my demo mode, right, and consume all the time available, I also wanted to tackle one thing. So at Percona, we are fully remote company. We have folks now in more than, I think, 40 countries, and including Ukraine. So we have like 25 engineers out there. My co-founder is from Ukraine as well, right? So we were quite impacted by the war which started out there. So we printed a bunch of T-shirts for our staff, like one I'm wearing. And we have our own conference last month in Austin, United States, and I got a bunch of people saying, hey, can we get some of those T-shirts as well? So we didn't have those for that conference printed, but I brought some for you. And yeah, when you guys are leaving, you feel free to grab one. Let me pull the box, which I didn't have a chance to unpack for you before the conference. So yeah, I'll probably leave it here for you. They just look like this one. Okay. Yes, demo mode. I will need my mouse. Okay. Now, that is a moment where things tend to magically break. So let's hope it doesn't happen. Okay. Oh, yes, look at that. We have it looking, and this display has a pretty good resolution, right? Yesterday I had it much more. So, okay. Let me start with this. So if you run MySQL or any other database, and if you really say, hey, from a very high level, what exactly do you need that database to do? And that is actually rather simple, right? You expect that you, from your application, you can connect to the endpoint, right, to the service that database provides, and then you're going to run queries, and you're going to get them queries to execute it quickly and giving you correct results. Right? In many cases, correctness you can validate during your tests, right? That is their performance, where you often see things in production. Because as data changes, right, as workload changes, performance of a query can be impacted a lot, right? And so what we provide in this case as a very important feature is their ability to look at the queries. Yeah, let's hope its internet is loading reasonably fast. Low? Okay, reasonably fast. Well, anyway, so what we can see here is the set of queries which all your servers, which are in this case connected to PMM, are running. Why is that? Well, because in many large application environments, you wouldn't just have one server, right? Often you'll have something like a sharded environment where many servers run with similar queries or something like that. And in this case, you are able to see the queries which are causing the most load on your system. If your goal is to say, hey, I want to see how I can optimize the queries in the system, well, that is something what you can go ahead and go through the list and analyze. Now, if you're saying, well, you know what, I actually want to look at the queries to understand which of them are slowest, then you can reorder the queries and say, hey, these are the queries which are slowest. Maybe focusing on optimizing them gives their most amount of value. Now, we talk about the load here, right? What is load? Well, if you think about what queries can cause the load on the database, that can be either queries which are very frequent or queries which are just heavy, right? And by multiplying those factors, we pretty much came up to the metric of a load, which corresponds to how many queries are actually running at the same time in average, which you find as a very good identifier, right, in this case. And what you can see here is what the QPS does not completely correlate with the load it creates. We can see what the first query is actually not not the most frequent one, right? It just has 25 queries per second. While the most frequent query, which has 1,000 queries a second, is what is like query number 5. And that is something very likely you find in your environment. Now, the queries view on your environment is only one of the views you may want to take. There are more, right? You may also look at to check instead the load on the different database nodes, right? In many cases, in a sharded environment, you may find what you expect. All the nodes should have approximately the same load, but one of them is overloaded for one reason or another, right? That is a tool which can show you their load from this standpoint, all right? Oops, that should be schema. You can also look at schemas. In many cases, when you have a sharded environment, for example, you shard the data and have a schema per customer, that can be very helpful to say, oh, well, this schema XYZ is the most loaded, right? So customer X is causing the problem on the system. And again, it doesn't have to be just loaded, right? You can also look sort for schemas by the query time and so on and so forth, right? Another find is a way to look as in is application name, right? Why is application name, or username is important? Well, one, it obviously tells you what user specifically generates the most load on the system, right? So you can maybe go and chase someone. But in many cases, you may be using usernames, different usernames for your application, so you can find what application is particularly guilty, right? And maybe you will see some, application which was generating normal load, and then after the new version of that application was deployed, boom, right? You have a huge spike because they either broke something, right, or you broke something, or you introduced their well, some bad query or something. So that is something what we think is quite helpful. And finally, you can look at that from a client host standpoint. Why is that important? Well, again, in a large environment, you would also have your application deployed in a multiple instances on many nodes, and it is expected that all of them supposed to work in the same, right? In a perfect world. Well, reality is our world is not perfect, and there may be quite a few different cases why you'll find the differences. Like, one is the code deployment didn't work correctly. One of them still runs the old version, right? I've seen that many times. Another reason maybe, well, I'm using some sort of a caching system. Anybody use Memcache, Redis to supplement database? No? Nobody? Okay, good, yeah. So that is a very common practice in a high load environment to reduce the load on database. And if you have missed configuration, right, or for some reason, the cache is not reachable from one of the application nodes, it may be generating hundreds of times more traffic than you expect to be, right? So there could be quite a few things, and pointing out, oh, you know what, the load is not as uniform between my nodes as I expected. That can be very very helpful. Okay. So if you look at the other the feature here, we can also drill down with our view of the queries, right? Because saying, hey, all queries on all servers, that is not particularly helpful, maybe for us, right? If we need to do a fix somewhere, that's maybe on a specific server. In our case here, we can see what majority of the load is generated by MySQL 4, right? So that is the node which seems to be having some issues. When we drill down, we can even more so see what TPC C1 schema is the one which is responsible for majority of load, and drilling in, you can see only queries now which are running on this particular schema on this particular database, and you can review what may be run out there. So in this case, if you look at their update query, right, we can see in more details what kind of metrics that query creates. But let me look at the other query for example here. So what the idea with for us was how we can help you providing the tools what you can have DBA developer, right, to then not find just those queries, but help them to understand what is wrong with them, and how to fix them. So what we can see here in this case, so this query is not very frequent, just 8 queries per second. And now, but another thing what you can find is what that query crunches almost 1 million rows a second, right? So that is something I think is a very typically valuable way kind of to think of databases. If you have database server is packed with CPU, right, uses a lot of CPU usage, then most likely there is a lot of row crunching going on, right? Okay. In this case, that query is doing indeed a lot of row crunching for this small box. But I think what is the most interesting here is this metric, right, which what you can highlight, right? So this query, it has to scan 100,000 rows for each row it sends. It sends back to the client, right? That is very helpful metrics, because if you think about like a simple query, let's say query goes and selects the data from a table by a primary key. How many rows does that query have to examine? Just one, right? So in a perfect case scenario, you would have just one query, right? The one row examined for row sent. And in this case, that is 100,000 times more. Now, in general, if you have the query which does not have a group by, these numbers for well-indexed queries should be roughly similar to number of tables you have in a join, right? So if you have 5 tables in join, maybe you will have 5 rows examined for 1 row sent, right? One from each table, if everything is kind of perfectly indexed, right? So 100,000, right, is not good at all. With examples, we can see example of this query, and that query does not do any kind of nasty group by or any other things which would be a good reason to examine a lot of rows, right, for row sent, right? Group by distinct is another example, right? It just selects the data by what looks like a primary key. So let's look at explain. Anybody familiar with explain? No? Okay, some hands. Well, so if you are working with databases, that does not only correspond to MySQL, any other database, right? Learn to use the explain, and always explain the queries which you have created or your ORM framework done for you before putting them in production, right? Especially if that's kind of high-load applications, right? Because that is, explain can show you how queries are going not only work, but also to scale. Because one nasty thing, I think, what often makes developers makes to hate databases is this kind of non-linear regression as the data grows, right? So often we would test our application at relatively small data sets, right? And then if your queries are good, then often as you have your database 10 or 100 times more, the queries will have approximately the same performance, right? If they're well indexed and so on and so forth. That is what indexes are for, right? To be able to be fast with a very large data. Now, if you have a bad queries, then you may have absolutely different story. You may have queries to become 1,000 times slower when your data size increased only 10 times, right? And understanding explain allows you to understand what kind of query you're working on. Of a first type, which will work very well with a large data set, or on a second time, right, where just a little bit new users, right, and it will take all your applications down. Anyway, so what you can see from this query, and this is kind of not explained tutorial, right? But one thing you would find here is what the type is all. That means it is doing full table scan, which is bad for something which looks like lookup by primary key, right? And it's expected to scan about 100,000 rows, right? The number is not exactly 100,000 here because explain shows estimates, but estimates you can see is pretty good, right? Within 1%. So while scanning their full table is not a good idea, well, let's now look at the table. Right, that is a third missing component, right, in this case. Well, okay, we have explained why would MySQL choose such a stupid way to run this query. Well, and the reason is, in this case, we see there is no indexes, right? Well, of course, no indexes are here because I dropped them, right, for demo setup, but that often can happen. Right, what we, especially with schema management, maybe you say, hey, I add the index and index addition fails on one of the nodes, right, for whatever reason, you know, lockup of a node was restarted in a process, right, or something. And schema can drift between different nodes, and some of them may miss the indexes which your new application version requires, creating something of this situation, right, what you can see here. Okay, make sense? At this point, any questions, thoughts? Tell me, Peter, you're on, or something like that. Anybody? Come on, let's increase the level of interactivity here. What about login? Oh, you see, yes, he knew my soft spot. Right. Well, login. Yeah. So right now, right, in PMM, we do not ingest logs, but we will. Right. That is one of our plans. Open telemetry. So in this case, well, we started on this project right before open telemetry materialized, right? To Frank, right? So it does not use full open telemetry per se, right? For metrics, we use Prometheus protocol, right? Like specifically, we use like Victoria metrics, right? Which is kind of Prometheus compatible solution, but which you can scale out, right? And for queries, we have our kind of custom storage and processing. Yeah, well, that is something that we are looking at, but that is not specifically scheduled for any telemetry. There's any specific delivery. Okay. Well, let me now maybe show a couple of other things which we have. So another thing what we have, which I want you to maybe talk a little bit about, is this, right? We have this a little dashboard which talks about the node, right? And I think that is a very something very important for developers also like to be like operation folks, right, to be aware of. Well, database is obviously very demanding application, right? And that only can work as good as hardware and software and operating system is healthy. Right. So in many cases, beyond looking at the queries, it may make sense to also look at your hardware node, right, and specifically to question what kind of resources that you have available and how they are being used. Right. If you think about the database, there are 4 primary resources, right, which really can be driving its availability and performance, right? There is, of course, CPU, memory, disk I/O, right, and network. So let me just go through them, like, and I said what I like to look at them. So in terms of CPU, you probably have like variety of tools, right, where you can see their graph similar to this, right? To say, hey, you know what, we are looking how much CPU is being used on this node. And if CPU is completely packed, well, no more CPU resource available, that is bad, right? And that means, well, maybe we can swipe a credit card, right, and get a bigger node with more CPU and get a better performance, right? But we can also get some more insights from a CPU usage, right? Which I show at this graph. One of them is important thing is to analyze how much you can actually benefit from adding more CPU. To what extent your CPU resources are overcommitted, right? And imagine this scenario. Let's say you have a single-threaded application which is doing some computation, and you run it on the node which just have a 1 CPU core. You will see CPU 100% packed, right? But if you give that application much more, 64 CPUs, how much faster it will run? It won't run any faster because we said, well, that application is a single-threaded, right? That is where, and in another case, you may say, well, you know what? I actually have, 20 applications, right, which are waiting for in the CPU queue, right, for CPU to become available. In this case, if you add many CPUs, right, things can run much faster. And you can basically see that by their looking at a normalized CPU load, which basically tells us how many processes, in average, are waiting for CPU to be available, right? The second thing which I find very valuable is the max core usage. The max core usage tells us the maximum usage of a CPU core. Why is that important? Well, because in MySQL case specifically, single query basically uses single CPU to operate. So if you have some heavy queries or maybe kind of some bad job, you may see your CPU usage is relatively low, but things are kind of running slow, right? But then you'll see, oh, I have 1 CPU core which is completely packed, and you know what? Adding more CPU cores are not going to help in this case, right? You really need to sort of like deal with that packed CPU core, maybe parallelize or optimize your application. The second thing I would mention memory. If you look at the database, memory is pretty much used as cache because memory is much faster to access compared to a disk storage, even if you're talking about some highest performance SSD, Optane, right, and wherever. Memory data accessed in memory is still orders of magnitude faster, and because of that, we like with database a lot of memory, so significant portion of data can't fit in it, right? Now, what may happen though in this case, if you allocate too much memory, more than you actually have available, then you will have a swapping starts to happen. And swapping is bad for performance, right? So at the same time, when you look at your system, there is going to be probably some garbage out there which is not really needed to run in your workload, and it is good to give operating system some swap space so it can put that non-needed stuff to the swap and have more memory available for real database operations, right? So what that means? That means first is A, good idea to give some swap, right? B, it's good idea to watch on a virtual memory consumption, not just your physical memory consumption, because if you run out of swap space, guess what will going to happen? Well, the database will crash with out of memory, have to go through that kind of recovery process, right? And well, you probably don't want to do that, to see that that happening. Then usage of some swap space is okay. On itself, right, do not see like, oh my gosh, I have 100 megabytes swapped out, I should now tune something. It's not a problem, right? The swap activity, that is something which corresponds to you overcommitting memory, right? Most likely. Right, and then you may want to reduce some of buffers to do that. So next is disk I/O, right? Databases again tend to be very I/O intensive, especially with our for large databases. Now, what is interesting with I/O, in many cases, our I/O subsystems are very complicated, and they're kind of can be shared, especially in the cloud, right? Like where you kind of CPU may be sort of, let's say, allocated to you, well, at least in many cases, right? Where network attached storage is shared by a lot of clients, right? And that is why your its performance may kind of ebb and flow, right? The other interesting thing with the storage is how much concurrency with storage can happen is also kind of not very clear. I mean, if you know, like, was like 10 or more years ago with Spinning disks, it was so simple. The single disk can handle only one request at the same time, right? That's just how it works. Now, if you take a look at the, like a single SSD, it actually has a lot of parallel controllers in it, right? And it may be very capable of handling like 20 requests at the same time, right? Or even more, right? So that all makes things complicated in terms of how storage responds to the increase in load. And with that, what I like to look at is look at the disk latency, which I separate reads and writes separately, and look at the latency what I'm getting from a device right now compared to the average over last hour, right, or whatever time, right? In this case, if a latency for reads or writes spikes, it is very often what you spiked significantly when you found the cause of your performance problem, right? And the reason of that may be one of those two things, which you just have to sort of look for other items. Either you are getting so much more demand on your system, right? Like you also see I/O activity spike. So it's natural what the I/O system becomes saturated and overloaded, right? Or if you see I/O load stays the same or even kind of goes down while latencies increase, that means something is going wrong with your I/O subsystem. Right, something happened, what it just became slower. Maybe you have some, noisy neighbors, have applications overload. Maybe there's, let's say, some, funny things going with your SSDs, right, and so on and so forth. Okay. Well, with that, that is all the time I have. I want to be respectful to the next speaker and give him time to transition. But I would be also happy to take some more of your question. Here and outside, and yes, please help yourself with some of the t-shirts I mentioned. Thank you.